Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Hey, we got sound at long last. Wow. Hey, we're up. We're rolling. Wow, we've got a project. So, we'll do a quick update, and then we're going to look at data tables and deserialize. Ooh, that could be fun. Deserialize. It's funny, if you look that up on Google for the Rust language, the only thing you really get reference to is a crate called Serde. Serialize and deserialize. Serde, yeah. Or Serdes. Well, from the last episode, we're not using crates, so that's going to be a bit of fun. I'm going to have to make some up. That's a damn shame. Data tables. We'll talk about that. Alright, goals for today. See if we can create data tables. That sounds interesting. Alright. Last time, just as an update, we were doing a clock. And I ended the stream hesitating whether this was good enough. And I've looked over it. I've written in all my comments and everything and looked over it properly. What you might call a code review, but it isn't, because I do it myself for my own code. So I reviewed it all and decided it's not good enough. Well, if we look down it, we've got a set frame rate limit with a U32. Well, if we don't want a frame rate limit, we put a 0 in there, and then we go and divide by 0. Yeah. Well spotted me whilst programming that. And we also know, due to this experimentation, that using float 32s is... These are all float 32s, aren't they? Yeah, they are. Float 32s. The accuracy is a bit dodgy. In fact, that accuracy is quite a lot dodgy. When I started calculating the offset value, and I also said that the offset would be computer dependent. It isn't. It is, well, it is, but it isn't. It's also dependent on how much your computer is doing at any one time. As soon as I came off stream and tested this out again, which I had to do, I had to change the number. Yeah. Which is why it's different. I think we had 185 or something in there. So your computer doing other things affects this calculation. Isn't that great? Well, yeah, we'll come back to that. Let's see, what are we doing today? We're doing data tables. That was it, data. Why data tables? I mean, that's going to be the question that everybody's going to ask, isn't it? Why are you doing data tables? Well, we tried ECS, and we're trying to avoid object-orientated programming. And you'll see a lot of discussions on the internet about OOP versus ECS. Don't read them. They're all a load of bull. The paradigms, that's all they are. They're just ideas Thank you, Windows Security, for that. Let's dismiss that message. They're just paradigms, which means they're a way of doing things because people say they are good ways of doing things. Yeah, right, of course they are. We've discovered problems with ECS because that's what I've been working with recently. We've tried out 2 crates and neither of them really satisfied what I was trying to do. So when something like that happens, I go back to when I started programming 45 years ago. We didn't have ECS, we didn't have OOP. What did we have? We had a machine with 8K of memory. Yeah. I had a machine with 16K of memory, didn't I? Yes, a BBC Model B. I had a big machine in those days. And we weren't bothered about this kind of thing. We'd stick all of our data into an array and be happy with it. We didn't care. So I was thinking, how can I do something that's not that? Because I'd like at least a system there that we can access, save out. I mean, saving out on ECS data, well, I never even went into that subject because it was just like a can of worms to be opened. I could already see the problems. So I want to try and resolve that by doing something simple. Read me text. Yeah, we tried SFML, we tried specs with specs derived. We never got around to trying out eGUI. Interesting. I have tried it out. Seems a bit verbose for what it's doing. As we won't be using crates, we'll have to do our own GUI system. That's a damn shame, isn't it? They're not hard to do, actually, once you get it all going. Workspaces and stuff, yeah, we're okay. Right, so time dev. We are going to be revisiting time. I'm sorry. It is a can of worms, and it is very, very, very difficult to get right. People think, oh, but it's simple programming. No, it's not. It's a lot of thought has to go into it. The funny thing is, you'll never produce a lot of code. So we're going to need a new project. Oh, my keyboard's wandered off. Hello, keyboard. Where's my coffee? And welcome, viewers. So I think I've alluded to this before. There's 2 priorities. Priority number one is the user of your application. Priority number 2 is your data. Yes. Data is one of the highest priority aspects of any application. How you store your data, how you retrieve your data, how you use your data, what you do to your data, the results of your data. Is it accurate? Accuracy, data handling, all of that kind of thing. That's what programming is about. It's got nothing to do with these paradigms that go out. What libraries are you using? What language are you using? It's irrelevant. Absolutely irrelevant. You can do what I'm doing in any language. So if you don't like Rust, do it in a different language. Shouldn't be hard to do. Right, let's get a project up and going. We're going to call it data. We're going to have to put Deserialize in here. Deserialize. I'm going to put a Z in. We're going to go American today. I should be standard with that, but never mind. I've looked on the internet. Everybody's American with it, so I'm going American now. That means I'll be going to MacD's later. Data Deserialize, and it's a development area. Okay, let's have one of those. Lovely. We have one of those now. Put in the README file. I wish they'd do this for me, but they don't. So we'll pop that in straight away, and we can close this down. Alrighty. We've got a project. And we're in the right folder. Lovely. How do we want to set this up? Do we want to do the application blah 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 thingy again? Well, yeah, a little bit. Actually, yeah, we do. I want to set this up in a similar way that we've been setting up before. I think that's only fair. So let's do that. I'm just thinking we could just take it out of the other project, couldn't we? Probably a better idea. So the last one we were doing was time. I tried to keep everything semi-standard. Oh, we just did main and time. Alright, we'll leave it then. If we're doing it that way, that's fine. So this is data tables with deserialization. Lovely. Don't you just enjoy it when you get something like this? We'll put in references in case we need them. Setup is there isn't any, so we'll leave that. Are there any references I want to put in straight away? No, because this is from scratch. We'll see about that. Oh, we've got Hello World, have we? Alright. We can run that, just make sure everything compiles. There you go, Hello World. I'm going to call it data tables. Again, I always change the Hello World to something that's more useful. So there we go. Welcome to data tables. Oh, I'll pop another one of those in. I think we're okay with that. Lovely. So that's just a welcome message, isn't it? Alrighty, we're going. Everything's hunky-dory. Do we need anything more? I'm thinking 2 files, maybe. So we'll have a module for data, I think, and we'll have a module for deserialize. Yeah. For now, I don't know whether we're going to need both. Quick fix, create. Quick fix, create. Just pop back to the README to make everything catch up. Thank you. I don't think we should need anything more than that, should we? No. If we do, then we're in trouble. We'll have to rethink our data. All right. We'll take it. We'll take it. Commit, edit, message. Okay. Base. Setup. God, this all looks familiar, doesn't it? There we go. We're not publishing, thank you. Right. Data. Let's think about this. What we're looking at is a data table. And you're thinking, well, what's a data table? It's nothing new. I'm not inventing the wheel. Well, I'm reinventing the wheel. It's nothing that hasn't been done before. If you're interested in tables and databases, because that's what they are, the basic way of representing data. So in the old days, they were called databases. And today, they're still called databases, 40 years on. Most famous one is SQL. Or SQLite. That's a good thing you could look up if you wanted to look at databases and stuff. But what I want to do with a data table is not a database. Well, it is a database, but it's an in-memory. Can we get rid of that? So, let's just call it a database held in memory. So we've got direct access to it without having to go back to the disk like you would do with a larger database like SQL or whatever they've got out there at the moment. And there's probably 1,000,001 different databases you can download off the net. And they usually require disk access and have their own languages for accessing and everything like that. Querying, yeah, query languages. So this isn't a new idea. So it's basically a table of data is a database. We're going to hold it in memory. And see if we can access it. Now I've put deserialize in there. There we go, and that's why. Because we're going to hold it in memory as strings. Why? Why as strings? Why have I chosen that? Well, if you remember back to our file input and output sessions, if you want to dump a file out to the hard drive, strings is a very convenient way of doing it. It means we can take our table, because it's in strings, and dump it out onto the hard drive into a file very, very easily. So this means that accessing our table, if we want to get a value, a float 32 for instance, out of our table, we have to convert it from a string into a float 32, and that's called deserialization, which is why I've popped a file in for it, in case it gets tricky, because we've got no references for it. I could have read the wiki, but I didn't. I'm just gonna make it up. So, how can we do this? Well, let's stay in English, shall we? Let's not get into any kind of programming language. We're going to need some kind of structure. That's for definite. So we may as well start with a structure. It's going to be a public date struct. I'm going to go straight into code here. Data table. Like that. And this is going to hold our data tables. Okay. We can then do an implementation for data table. And put in things. Do I want a new table? An empty one? Probably not at this stage. Let's grab some data from somewhere. Okay, let's grab some data. Let's have some test data for our tables. We have had projects in the past that required data, so let's go and have a look what we've got. We had a sandbox, didn't we? And our data would have been in application info, which is why I had an application info, so it's easy to find stuff. Just open new. I'll just take those two. Can you stop doing that? Take those 2 lines. But I said I want this in strings. But we've already got an experience with file input and file output, so we know roughly how this should look. So we can convert this into a string. Let's do that. So we'll need that. We can take the commas out. That's nice. We don't need those anymore because it's a string. We can also add bat at the beginning. And at the end, if we're reading it off a disk, it'll have \n there. Because that will be a line of data in a text file. And at the end of it, it'll have a return carriage. It could be a \n, because we're on Windows. I'll ignore that. So we can put a \n in. So what I'm doing is I'm representing this as if it's a string coming in from a file from our hard drive or whatever you're using, SSD. And it would look something like that. So that's the kind of data we are expecting to use using our file in and file out, you know, load, save and load. That's the kind of format that we're looking at. And it's 1. It's not 6 anymore. I'm going to keep it. We don't really need it out like that, do we? Alright. We don't actually need it like that. That's going to cause difficulties. Because it's not a string, is it? It's an str. Let's just get rid of that. Let's see what it says. It needs it, okay. It's an str. I want to see what difficulties that gives us. That's going to go on the program memory. Ooh, I don't like that. That one's correct, that one isn't. I can't remember how this comes into memory from the file I/O. Alright, well for now, for test purposes, I'll go with string. So let me just try this out. I'm not sure how it's going to affect things, if I can put string in there or not. Let's see if I can. Could be interesting. So that's what the development area is for. It's all about testing, trying to find out what you're allowed to do, what you're not allowed to do. So if we were to say let test equal bat data, see if we're allowed to do that. Okay. It's not telling us what it is. Is this going to be a real cock-up? And that's what I want. These are the kinds of things that I need to know. How is our language going? Yeah, there we go. All the red squigglies. Cannot find string in the scope. Quick fix, import std string. Okay. Found module string. Similarly named struct string defined here. A struct with a similar. Do you want a capital S? Okay. I'm guessing that wants a capital S as well. A built-in time with blah 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 la 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 la. Okay, right, yeah, this is what I was expecting. And found and str. Okay. So and str. There we go. Got the bottom one working. And this is the problem that I was thinking. Now it's trying to tell me that it's a string. So we would probably have to have an str here as well. There we go. That should now work. I was thinking about. I haven't thought about this. Damn me and me thoughts. Never mind. Yep, comes up. There we go. Bat 500 500 120 00. That's the data. So we can use our data like that. Okay. Fine. So that works. We've got some data. How do we represent this data? Well, if you notice, that looks like a row of data in a table. So let's call that a row. Okay. So how are we going to represent our data? So data can be held in rows. We just discovered that. So what we do know then is that one table will equal a vector, because we don't know the size of it, a vec of rows. We can't use an array because we don't know the size. Arrays, you need to know the size. In my mind, that's the use for arrays, is a set size of data, where vectors are an unknown size of data. So let's use vectors. Okay. Think we can do that. I'm going to use a function, aren't we? Yeah. So we're going to have a public function create. So we'll have data table create. Yeah, that's okay. That's gonna take in self. No, it's not. It's going to take in nothing. It's going to give back self. Alright, we're getting somewhere already. And at the bottom of this, we just need to put in a data table, don't we? Like that. So that satisfies that. Right, this test worked out okay. We'll get rid of it. Create a table. Get values, get test values from the table and output results. Things are coming together. There we go. Right, we've got a program. So here we can just create a table, can't we? So we can have let table. That's going to be interesting. Data table create. Okay. And at the bottom, we're going to be printing something. So we'll have a print line. God knows what I'm going to put in here. Let's just put U for now. I'll put a comma and we'll just use table. Table, which we can't do. That's an error. But yeah, it's an error. I know it is. All right. So creating a table. Let row 0 equal bat data. Yeah, we'll use that for row 0 for a minute. There we go. That comes in as an AND string. So, okay, we'll just put row 0 in here. I do it the long way round because I'm an idiot. And it also means that I've got something that I can actually work with. So row 0. I'm just going to call this data, just to separate the names off. Data row 0. That's lovely. We've got an AND here that it doesn't like. Missing. No. This is being held on the stack. Program memory. I don't want it in the program memory. Okay. Let's try a string instead. Yeah, I thought as much. God damn you, computers. Yeah, as soon as you put something on the stack, you're going to need a lifetime. That's not what we want. Do I want this here? Or can we pass back a string? Huh. Alright. So we've got a table coming in. Table.row. And we've got no access to it. Let's make it public. Alrighty. Now you're talking. Everything works. I'm a little suspicious. It does say it's a string though. That's good news. It should give us exactly the same. Yes, it does. That works. Okay. Right. We have a starter for 10. We do have the ability to make rows. That's not much good, is it? No, it's not. Because we don't want tables with just one row in. We'll want multiple rows to create a table. So this is where the vector comes in. And this is where I get a little bit lost on how to create this. So let's find out. Let's find out how we do this. Let table. Yeah. And we're going to need a vec of strings. And if I remember rightly, this is one where you put it on the wrong side, isn't it? Yeah. Alright, we'll pop that in there. Don't want anything in it. So I won't put anything in it. That means we should be able to rewrite this line. I don't know if we need the string from. Ba-ba-bum, ba-ba-bum. We can look it up. Load, isn't it? Not save. This gives back a vector. And it is string. We have used string here. Okay. We're using a vex string, so we are passing back a vex string. That's what I needed to know. So this is now correct. It matches. Good. So what we're going to do here is exactly the same thing, isn't it? Yeah. We're going to take our table. We're going to push a value onto that table. This now becomes a vec string. This is no longer a row, it's now a vector of rows. So this is the actual table itself. And all we need to do now is turn you into a table. And that should be okay. Something's not right. We've got this here. Oh, right. We've got the... we're changing you. And we don't need the rest of that line. Okay. 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 Yeah. Again, I want to separate this out. I'm looking for names of variables that are going to make sense in the long run. Okay, that should work. How do we use that? Well, we can't do this anymore. Public, yeah. I'm going to call it test table. So I've got the naming conventions different. That gives us a table, which gives us... How do we index that? Is it 0? Is that legal? Looks as though it is. Okay. And it still works. All right. So that's a legal way that we could look at it. So test table 0. Okay. For the moment, I'm just going to duplicate because I haven't decided how I want to handle this. So we'll take some more of that and we'll push into that. Another string. I don't like this string conversion. And this is going to be ball data. Yeah. I'm not overly happy about this. Because our data will be coming in as strings already. So this really isn't ideal. So I think I want to convert this to a string. So I'll just do that. So I was right about wanting to put this into a string format. So we'll have our test data in the correct format. What did you do that for? Strange. Okay. Getting used to the keys for that. Right, that's better. It still doesn't like it. Can't call non-const function string from as from in constants. Really? What? Okay. So we can't do that. And now we've got this. Can we do it that way? No. So we can't convert. Wow. Alright, fair enough. Stuff here. That's a shame. Now, can anybody see a problem with this? I can. Our bat data has extra characters in it. We'll have to deal with that. And I think we should deal with it where? Do we deal with it when we deserialize? No. Do we deal with it when we get data out of it? I wouldn't have thought so. Should our table contain just a string? No, it shouldn't. Oh dear. We have to deal with all of this in the creation stage, because what we have here is not a table. You see, a table has rows and columns. We've only got rows. Alright, we'll try and prove that. Don't know how this is going to react, actually. Shall we find out? As you can see, there's a for loop going on here. So we can change this in a second or two. Ba 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 ba. Am I happy with that? Yeah, I am. Let's get that tested. Yeah, can you see there's an extra line in between? I thought it was going to react that way. That tells me there's something wrong with our data. There shouldn't be an extra line there. So that \n matters. That has to be removed. So this \n is causing an extra line on the printout. It also means that it's going to make things difficult for us on deserialization. A little, possibly, I don't know. We need to remove it. That's the first thing. But we've got our strings now. That's good. We've got the beginnings of a table. But we can't deserialize it because all of the data contained within the string is all lumped within the same string. We'd have to traverse the string, find the data, pull it out, and yeah, no. That's a little complex. So wouldn't it be more sensible to store our data as individual values? Don't you think? So we need to deserialize at this point. So this isn't really going to work that well. What we're going to need is a deserialized table to go in here. We don't want to be storing our data as rows. We want to be storing it as rows and columns. This will mean we can then access it by the row and then the column. Which has a macro rule. I didn't know that. But that would be more useful to us, wouldn't it? So we can actually go into a piece of data, extract it and use it, change it, save it. There's another big reason why we want to be doing it this way. Memory. All of our memory is up front. Because one of the first things a program will do is initialize its data. And we can initialize all the data for the program at the beginning. We can also add rows whenever we want because we're using vectors. So we can add data. We could even have a table for variables or varied data for use within the program. Means that we don't have the upfront designation of memory allocation, but yeah, I'd have to think about doing something stupid like that. What we're actually doing is creating an ECS, but one that's a lot easier to handle. ECS is just a data compression algorithm. What we're not doing is doing the compression parts. No, it isn't an ECS at all. It's the reason why ECS was invented, I guess. Because it becomes inefficient, as we'll see. So what we need to do is deserialize it. No, we don't. We just want to split this down, don't we? So we need to convert this table data into a table. So this is table row data. Isn't it? Let's be honest. It only gives us rows. We want to form a table out of that. So we do need to be able to format this somehow. So we will need table data at this point. And that's going to equal something. Convert. I don't know. Something like that. Convert table? The table row data, convert it to a table. Yeah, okay, we'll go with that. This is not a function of data table itself. This is a generic function. Alright, so we'll just make a generic function for that for a second. Function, it's not public. Convert to table. It's going to take in table row data, which is a vector of strings. So this is just going to be row data, which is a vector of strings. Vectors are pointers. So a vec of strings, and it's going to give something back. It's going to give a table back of some kind. I'll just put an I32 in for a minute, because I don't know. I don't know what the hell we're going to be making in here. So let's just put a 0 down here. Now, yeah, we'll have to do something about that. How do we do this? Well, we've got that \n to deal with. Let's do that. So I don't really want to make this mutable. I'm going to need some space here. Let data equal row data. Can we trim it? How do we trim? Oh, it's a vec string, isn't it? So it isn't. It's row data. Let's just do the first one whilst we're thinking about it. Dot split trim Yeah, we can trim. Alright, we can trim it. That gets rid of that \n and any trailing spaces and any spaces at the front. And it returns and string. So let's put it on the stack again. Okay. I'm not going to do a conversion there. Once we've got it trimmed down, we can now probably take our data with half. No, we don't need to, do we? So this is going to be columns. Let's see what happens if we take our data and we split ASCII white space on it. Oh, we've got something horrible coming out. Unzip. Unzip? Really? Unknown, aha. Collect. Can't do. Alright, can we do it here? Yes, we can. But we're not getting a type now. It's just saying unknown. Okay. Do we need to put a string from here? I'm uncertain of this command. I don't know enough about string manipulation within Rust to create. We're close. What we're doing is we are going to split string str. Got a mute on there. It's not liking this. Split a string into a vec. this is interesting. Nope, not using that site. Well, let's see what we've got here in the standard library. Split next, split remainder. Yeah, okay. That's all really great. Split ASCII white space. Split ASCII white space. It's a next. Yeah, okay. We've got an iterator. That's probably why we're getting all that stuff. This isn't too clear on how we want to do it. Type must be known at this point. The type must be known at that point. They're not really giving too much away here, are they? I don't want this next thing in. Why is this thing so... I'm finding the manual a little dodgy at times. Yeah, it's just giving that. Yeah, you're just splitting. You're just splitting on 1, 2, 3. You can do that, can you? Collect. Ah, I see. Is that what it's on about? Because that's something that sounds interesting. We'll have that as a vec of string. Am I allowed to do that? I bet it's undes... Yeah, that will give us a vector of strings. But we don't have strings, do we? We have STRs, although I'm asking for it. Yeah, we've got this STR. We've got a silly conversion going on here. Let's see if we do a string from here. What happens? That would go there, I guess. Okay, what are you having problems with here? Yeah, I agree with that. Cannot be built from an iterator over elements of type and string. Yeah, you're doing that again, aren't you? Okay. I agree. So we're constructing something that might be useful. Don't think we really want... Aha, ha, 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 ha. What's wrong with you? Is not satisfied. Oh, right. This is interesting. Do we have to convert everything over to strings? Is not satisfied. Huh. What it's saying is and str here. All right. That's not what we want. String manipulation seems to be a little bit dodgy. How do we get that into strings? Because that's our code. The row of data has to come in as normal. Hold on a minute, we can alter this. It's gonna come in as what? Right, we've killed this one. That's nice. We don't need that. We only want to be doing one row at a time. Not sure about this. Okay. You're probably wondering why I'm trying to avoid and str. It's a string, literal. And string literals, you can't mutate them. Even though it says I can. Shall we just go down the string literal? Let's go down string literal then. see what happens here. It's pushing us that way, and there must be a reason for it. So the programming language is pushing us into string literals, which I don't want to be using, because we might have a lot of data, and if that's all on the stack, we're going to run out of stack, aren't we? We need to convert it somehow, someplace. That's now wrong. Well, it should be. And it's not saying it is. Ugh, I don't like this. I don't like this at all. Yeah, that's exactly what I was thinking. So the language agrees with me. Okay, that is not the way to do it. La 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 la. Okay, we're happy with that. We now can't push that on there. Because we're holding that as a string literal. Okay. I don't like what's going on. And I'm messing around with it all to find out what I'm allowed to do, what I'm not allowed to do again. See what possibilities we've got. That now becomes wrong. So it's coming in as a string. And it's converting it over to a string literal. Yeah, I'm okay with that. Don't care about that for a second. I care about this here. How do we get a string out of it? Are we allowed to? So if we split and str to a string, how's it doing it? It's just giving the same results. Oh no. We could just use split white space. You know, No, we're not using that page either. It's asking for cookies. Alright. See, they're getting vec and string. Splitting by a character, splitting by a string. Yeah. Alright, we'll do it that way. Splitting once. They're always returning a vector of and string. Okay. They're not, that's not helpful to me. Do I mind? Yes, I do. You see, and string itself, or and str, is not the same as and string. I'm going to try something stupid. Alright, no, we can't do that. I agree. Right, so what's the problem? A value type vec string cannot be built from an iterator over elements of type and string. Okay. From iterator string. How do you implement that? Yeah, we've already worked out the pushing. Oh, you can do a push string. Oh. Unwrap. Bloody bloody blah. Unicode. We're going to have problems with that later. Then it goes off into its wonderland of doing silly things. Oh, God. Could we dereference it? There's something in here, but how do we get that iterator? How's that used? how is that used? And this is where I have a problem with the manual. I understand what it's saying, but required buyer bound in collect. Hold on a second. Can I take that information copy it and pop it in here? We can. Conversion from an iterator. Really? Conversion from an iterator. Is that coming? Yeah, it is. I think it's coming from here. So if we do vec from iterator, yeah. So we could have just put in from iterator. That's what it was telling us to do. Huh. Oh, that did something. You're after a colon, aren't you? Uh-huh. I wonder if we do them separately. Yikes. You see, this really isn't. What's the quick fix? Use da 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 instead of da 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 to specify lifetime. Type in const args. Yeah, okay. Don't see what you're trying to say. Alright, it's actually giving us something more sensible now. Expected function, tuple struct or tuple variant found trait from iterator. maybe it's to iterator. Hold on a minute. Maybe it's getting this the wrong way round. Alright. Two owned, try fold, try for each, try fold, try into. Ooh. Okay. Right, by ref, cloned, compare, count, cycle, enumerate, equal, filter, find, flatten, into iterator. Ah. Two owned, try fold. No, you're not really giving us a string here, are you? Alright, I've spent enough time on that. That's the correct answer. It's not what I want, though. Okay. Carl. We'll try it here. See if we can convert it after the fact. Carl. We just get a string. We don't get a vector of strings. Yeah. Alright, that's all understandable now. Alright, we're going to leave that for a sec. But we can now see that the language is stopping us from doing something stupid. And that's a good thing. A lot of people will get frustrated at this point and say, well, this doesn't make any sense. And quite honest with you, the manual isn't really being that helpful. It's just giving confusing examples which don't really mean much to me. Yeah, right, whatever. I can pull an iterator off it, but I don't want to do that. So this needs research. This isn't right. Okay, so now we've got a vector of strings, we should be returning it, shouldn't we? Let's see if that will work. We also need a for loop. So let's do that, because we're only doing one. one row of data. We want to do all rows of data. So we need for line in row data. Something like that, I would think. Okay. That becomes the row data line. Now, why am I not allowed that? Oh, that gives us the actual line. Oh, that's nice. Okay. Lovely. So I'll put line in there. We've now got our columns. Or we suspect we have our columns. I wonder if we're going to get an extra one. Don't know. At this point, I'm going to do a test, as I'm not sure what it's giving us. You want a vex string still, don't you? We'll cheat. We'll just leave you as that for a second. Why don't you like table row data? Use of moved value table. Oh, right, we're now moving it. Yeah, of course we are. Table row data. How can we stop you from moving? I don't think I want to. Let's return this value. So we've got columns. Alright. Let's pop you in there. You are a vex string. So let's pop you in there. God, this is easy. He says experimenting with it and banging his head against brick walls because of his lack of knowledge of the language. Okay. We don't need that as mute. Alright. What's wrong with col? We've got an and in there. Cannot find value col in this scope. Of course you can't. Ah. Because you're in the for loop. Vec string. Yeah, okay. We'll do that. What is it? Vec, pling, yeah, that thing. Lovely. Okay, that's alright. We've got a mutation here that it doesn't like. Does not need to be mutable. Okay. What's wrong with this? If this is intentional, prefix with an underscore. Alright. We'll deal with you when we get to you. Why didn't that format? Why won't you format the document? Okay. It won't format the document because we've still got an error. You might want to return an own value string. You're taking the piss. Yeah, that's exactly what I want to return. How did you know? You can see the problem now that we've got a mismatch of information here. Okay. How to cast vec and str to vec string. Blah 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 blah. Map. Oh, we've got one of those things, have we? I've never done that before. Alright, let's try that. We've got an answer. Then it's just collect. Alright. This seems more reasonable. Let's just get rid of these brackets. So we can map it, can we? Well, that's an interesting thing that it didn't really show us in the manual. Thank you. So it's saying that we can map. We're going to have an intermediate variable. So we'll need one of those. That's a pipe. V. Doesn't really matter what it is, does it? I'll call it S. For string. Pipe. So we've got an and string. Yeah. That's nice. And then we're going to take that. This means subfunction, I believe. These pipe symbols. S to string. Okay. Dot collect. That's a function. It's not giving us anything here. Does that work? Not if you've got col here as a string, without the string. Alright. Type annotations needed, implicit satisfying. Yeah, from iterator string, found in the alloc crate, right. Implementation from iterator string for box string. Type must be known at this point. So we've still got this collect thingy going on. Yeah, we have. am I supposed to do that? Yeah. Oh, I'm hating this. Dooba-dooba-dooba-doo. Let me just take that. Take ourselves back to here. Gotcha. Take ourselves through from here. Gotcha. We want to change you to a string. Got it. We bloody well got it. Can we just take you off now? We've got something reasonable. Wow, that's a command and a half. Yeah, we're not using you. Okay. Why do you insist on not being used, you horrible person? Right, we've got clean code. We've got clean code. We've got something. We have a hell of a thing going on. We've got all of that going on. Alright. So we're getting split white space, we're getting string, we're getting an implemented iterator item which equals a string. Okay, and then we're collecting into a vec of strings. We can then return that. But what have we actually got at this point? So this is now coming back as a vector of strings. Let's have a look at this vector of strings and find out exactly what we've just done. Shall we? So we're just going to pop that into our table data, and we're going to go back to main now, and we've still got the same test going on. We should get rubbish. Please tell me we get rubbish. Oh, we panicked. Index out of bounds. The length is 0, but the index is 0. Oh. Why is that? Exit code 101. La, 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 la. Control click. So when we get our test table back, our table hasn't been constructed. Somehow. Ah, we've still got this going in as well, haven't we? We are doing both lines, but we're not separating our lines. I see. Yeah, this is wrong. Don't worry. But at least I've now got some idea of what we're allowed to do. And this is part of deserialization, by the way. Being able to convert things. So we've got our first big error. Wow. That's cool. Which means this return value dies. We're returning the whole thing, but it's a pointer. Ow. Do we have to deref that? Now I know why it was doing and string. Do you know why it was doing and string? We're killing everything, aren't we? If I move this code into here and it gets stored, then it's fine. If I have it in a separate, it's coming out of there and that gets killed, by the looks of it. Possibly. Memory management. Who needs it? We do. So I've caused myself a problem. Can I debug this? Are we allowed to do that? If I put in a breakpoint, install code LLDB. Oh. Alright. Won't do that then. Do 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 do. Table data, yeah, okay. Table data length equals whatever. Don't use equals. Because that's a bad idea. We'll take our table data and we'll just find out its length, please. Yeah, okay, that'll do. And as we are crashing here, maybe here, let's find out what we've got. I think it's because we're only doing one, but don't quote me on it. Let's just run that. Find out what length we're getting. Table data length equals 0. Yeah, we're not getting a table. Okay. So let's have a look at our debug. Find out exactly what's going on here. This is in a for loop. Can't put a string in. Okay. So this is col. We'll call it 1 for now. All I'm going to do is put in col length. I think it's destroying it because we've got this goddamn thing here. Col dot length. We'll pop you in there. We'll also do an extra print line here. For col 2. And we'll give a col length there. Let's see what happens with you. Just printing stuff out. So the column length is 7. It does it twice, 7. Then it goes to 0, it gets destroyed. Because it's a pointer. Table data length equals 0. So it gets destroyed there. Our data is being destroyed. How do we get around that? Simple. He says. We stopped doing this for loop. Oh, we've got a let here. That might help. We were shadowing. And a shadowing gets killed. Ah. You see how tiny errors can just really mess you up. Everything is 7. But there's a problem here. Can you see it? 7, 7, 7, 7. We've got more data than 7. So that's incorrect. Watch. If we let, we'll just call it temp, go in there. Let's just get rid of all this rubbish here. It's just debug information. If we put that in there, and then we take our col, which is a vector of strings, and we do a push of temp and store it instead of just writing over it, maybe we might get a different result. Warning, data deserialization dev generating 1 warning. Could not compile data, yeah, blah, blah, blah. We got an error. Temp doesn't want to go in. Mismatch type, string, found, yeah. Oh, right. it would be temp 0. Is that correct? No, it's not. How do we put that into there? But I think you can see what I'm saying. We're not storing it, we're just overwriting it in this for loop. Which is no good. We could have an index. You see, this is a bit awkward. Because it's a vector and we want to push in a vector to it. Ugh. That's not good. Yeah, this code is wrong. We've got no storage. It'll do for now, for testing. We need to alter that. And why won't it format this? It will now. Okay. Temp isn't working. Okay. We'll just put you back to col. And we're underscoring you, aren't we? Yes, we are. Right, let's see what we're getting. We're only getting 7. If we're right, we've got something we can work with, I think. Oh no, it's all gone to 0. Oh, still got that bloody Latin. Okay. Make sure we've got data. We've got data. Alright, we have data. Let's have a look at it. We're using print lines, so this should be on separate lines. Let's see if this is now coming in true. Yeah, data, ball, and then 125. Is that correct? Ball, 125. Why are we getting ball data? Because that's the last one that we do. That's the last line that we do, so the first line isn't being saved. Yeah, that's fine. Okay, we can now convert data. We'll work out how to program that when we get to it. So we do have some data in our test table, but as you can see, we're not getting the rows. So really, this for loop's in the wrong place. Yeah, it is. The for loop should be up here. We should take each line and convert it separately. That would then come back with a vector of strings. Would that be useful? Yes. Where could we put it? Are we allowed to put it in the same vector? And would that be useful? Yeah. It would be very, very useful, I think. So we need to have a two-dimensional vector, rows and columns. Pretty neat. What do we think? I think we should be alright with that. Right, it's going to get pretty complex at that stage, isn't it? Because we're going to be converting all of this into one command. Alright. We're probably going to have an input of vector of lines. So this row data's fine. Alright. And it is in strings. Okay. Let's ignore that for a bit. We'll come back to that and program it properly. I've already worked out what we need to do there. We need to have a different conversion style where it's taking in a string and sending out and returning a vector of strings. Yeah, that makes more sense. It makes a lot more sense. We can get rid of a for next loop. The for next loop comes in here. How we put that vector of strings into a vector, I'm not quite sure. I'm guessing we'll work it out. We've worked everything else out. Okay, deserialization. What do we need to know? Well, we already know that we're getting information in. Not the right information at this stage, but it doesn't matter. We've got a ball and we've got a float. How do we deserialize that to ball and float? Well, ball should be easy because that's a string. So let ball name. Now this is row name. That's going to be that one. That one's simple. And that's a string. Ah, but the first item of data is left. So it's going to be the left data. Now deserialization means we need to convert this into its type. cannot move out of index of vex string. Move occurs because value has type string, which does not implement the copy. Okay. So we're only allowed to take references, which is correct. So this now becomes row name. We can take this out now. No, I'm not going to. We'll just take this bit out. This becomes left data. I'm going to find out why I've called them that and I didn't put in row 0 here, or row 1 here, because it's going to change. Okay, should give us exactly the same result. We agree on that, I hope. It does. Excellent. That is allowed. That's the kind of thing that I want. We're pulling data off the heap. And we're doing it properly by using pointers. God knows how we're going to amend these datas. Problem is, left data shouldn't be a string. It should be an F32. How do we convert that to an F32? Well, can't do that because we'd have to dereference it. So we can't convert it there. We would have to send this reference to return an F32 is the answer. What's wrong with data? Oh, it's just modified, okay. Alright, so now we're into here. Deserialize. Strings into the correct type, variable type. That's basically what Deserialize does. So I may as well say it. How do we do that kind of thing? We'd need a public function to do it, where we take in a string or a reference to a string. Yeah, that's sounding about right. So we would have deserialize. We're just going to call it that for now. We would take in our data string, which would come in as a string. It would have to be a reference because we don't have anything else to mess around with. And we have to take that information out We're going to do deserialize F32. That's all we're going to deserialize to start off with. Alright. How do we do that? Well, we take our string. We could do a match return. I think that's obvious. Let result no, I don't want to put it there. Let's not. How can we do it? If we take our string, yeah, let's see what kind of thing it's going to do to us. We'll take our string, data string. Data string, please. What do we need to do to that? Can we go to an F32? Don't think so. Try into. Could be interesting. What types? Okay. So, how to cast string to F32. Parse. Interesting. Parse float error. Oh my god, we've got an error on this. Alright. So it's data string to, no, it's parse. So I've got an unknown. I've got this colon thing. Let's try that. We're getting somewhere, I hope. We've got a result. Okay, that doesn't sound too bad. Do we just unwrap it? We can. I'm just going to query it instead. We just get the F32. If we take that off, do we get what we're after? No, we don't. We haven't dealt with the error. Right. We do have an error thingy going on here. Can only be used in the function that returns result or option. Okay. Unwrap. Okay. It's saying that that's alright. I don't agree with it. That can send and that can have an error. I don't like that. Can I use an expect? Deserialize F32 failed. Am I allowed to do that? I am. I'm allowed to crash things. That sounds better to me. I don't want it to continue if this fails. I want it to crash. Can I take that off? Don't think I can. It won't allow me to return that, you see, because it's got two different values. Alright, that makes sense. We'll just return it there for a sec. Alright. Will that work? Yeah, deserialization. This is our first attempt at it. I'm a bit dodgy about this. It doesn't quite add up. I'm going to try it anyway. Alright, data string goes in there. Okay. Says it's an F32. Did we just do it? Have we just invented Surdy? A whole crate in what, one line of code? It has to give us the same result. It does say it's an F32. I wonder. Okay. It's come out as 125, which is correct because we didn't put in that. It's still 125 because I bet there's no decimal places on it. But yeah, that is correct. Huh. Yeah, there's no decimal places. I haven't put any decimal places in here. We can check our data by putting that in. Yep, 125.5. It's picking up the decimal places. Yeah, that's what I wanted to know. Alright, that's fine. So we now can deserialize from a string to an F32. That's no good though, is it? Let's be honest. I don't mind this line because that line can be left alone. What we have to do here is develop a way of being able to deserialize any column to whatever that column variable type is. We're going to have to return an option T. I don't really want to. That's interesting. I'm trying to avoid options and sum. Is there a way of doing that? This is where deserialization starts getting complex. I don't really want to use that, so can we do that? Yeah, we can. Okay. Yeah. How do we get the information from what type we have here? Well, the simple answer is interesting. We'd have to fix our table creator. But that shows how easy it is to do, to be honest. So that's not bad. Our table data is garbage. So let's take away the for loop, shall we? Yeah, I think we do. We could use a push. How do we do all of this? You see, we haven't got a two-dimensional table at the moment. We've only got a one-dimensional table. Are we allowed to do something like this? For instance. Oh, gosh. It jumped at the idea of no. Oh, okay. Yeah, unstable. No. In a tuple. Okay. Let's wrap the inner parts in a tuple. We're allowed to do that. Did you know you're allowed to do that? So convert to table is going to be useless to us now. So each line, we have to go through each row. So this is this line thing here. So if we cut you out of here, we might be able to do this differently, don't worry. We'll see. Alright, so for each line in there, we're just going to pass in a line. Okay, that gives us a string here. Should we be taking that in by reference? Yes, we should. We shouldn't be passing strings around. They can get very big. We are still outputting a vector strings. Ooh, that's not good. We actually want to now output a string and a vector strings. So it's string, comma, ownership, be careful, it's a tuple. Alright, so that sounds better. Let's just get rid of the errors. Thank you. The data is going to equal that. We're adding it into a vex string. But we want to remove the first value. That's not needed. That is now row data. It's still doing this silly conversion here, isn't it? Let's check it. Yeah, you are. This isn't correct anymore. So this string is the very, very first value. How do we get rid of that? We can split. But I need it to delete. We don't need that anymore, because we're not doing that. This isn't convert to table, this is now convert to row, or convert row. Alright, let's do that. Yeah, I'm very particular about the way I do things. Table data doesn't have a length anymore because it's a tuple. Okay. So how do we access that? let's just put in 0, comma 0. Will that do it? Yeah. Does that work? Uh-huh. Not sure how that print line is going to work at this point, so I'll just do that. That's easier. It's not row data. It's table row data. Okay. We don't have any table data here. Yes, we do. Cannot find value table data in this scope. Because we haven't got one. We've still got this thing. Consider borrowing. Okay. I'll consider borrowing. Alright. We've got a string vec string. We don't have a vec. We're missing a vec. So this isn't our table data. This is an intermediate, an intermediary stage. This is one row. We need to add that to our table. Okay. So we need our data. Let's just put it up here for a minute. We'll do a mutable data type. We'll just call it whatever we've put here. For now. I'll just semicolon it. I don't know what I want to do with that. We'll pop you in here. I can just do that. Alright. That doesn't quite like it because isn't initialized. I know it's not initialized. Dumbo. So we need to initialize it. That would be our data. Can we just push on that? I don't think we can. I don't think that's acceptable. Cannot find table data in there. The binding table data is available in a different scope in the same function. Is it now? It is, you're right. Mute. I'll put mute on it because I've got a feeling that I'm going to be doing it that way. That's going to be a tuple. Okay. A string. I'm trying to make this as verbose as possible so I can boil it down into its component parts as we go. So I am doing it this way on purpose. I'm not going to initialize you either. I'm going to be naughty. Alright, so that's okay. We don't want a let here. Now, what's your problem? Binding initialized here in some conditions. Ooh, some conditions. Ooh. That's an interesting result. I think it wants us to bind here. And I'm not quite sure how you do that. Vec. We'll try that. Got a feeling we want that in brackets somehow. Like that. You're happy with that? Okay. Considering assigning a value. Yeah, I am considering assigning it a value. Thank you. That would be... Oh my god. Vec. That, open brackets. That... I think... And it's accepted that. Everything's cleaned up here. Now we've got a problem sending this back. Mismatch type, expected tuple string vec string. Found empty, because we haven't done it. So we want this one here. Yeah, this is no good. It is, but it isn't. Right. Let's just give this here for a second. I'm gonna call it row. Trying to not mess up my variable names. Okay, we'll just call it data for now. Okay. We're getting somewhere. That's the result we're after. This is what we've got. We've got that bit we don't need. Okay. What we need to do now is convert col into data. It's in a vector of strings. Can we just do that straight off in a stupid way? Probably. data equals it's going to be an open brackets because it's a tuple. We would have col0 comma col. That's bad, isn't it? What happens if I do that? Becomes a string. That's perfect. So that's row name. We've already decided what you are. Okay. What's wrong with you here? Cannot move. I don't want you to move. Row name, don't like it. Mismatch type string and string, so you have to dereference. Alright. Oh, don't like that, do you? Which is behind a shared reference. Yeah, that's going to cause us problems, isn't it? Does that mean we need an ampersand on all of these? I'm trying to give ownership. Damn it. We need to split that out. You can do a split, can't you? Yeah, we remember split. So when splitting instead of casting, okay, let's split instead of casting. To create an iterator, yeah. Why doesn't it search me the correct place? Why is it sending me all over the place? Split at. Slice chunks, oh my god. Yeah, Mount Clay, yeah, blah 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 blah. No, I want straightforward one, thanks. Split can do two different things, can it not? Let's try split. IO, slice, string. Oh, it would be str. Alright, let's look at this one. Okay. I see what you're doing there. Yes, split remainder. For each drop. So there'd be none. So it is removing. But what does split return? I only want the first. Can we not just have the split AP? Yeah, we can. Position. Must be. No, that's... Oh, Jesus. P is pattern. I just want to split the first item off. No, this is a vector. I want to remove the first item of a vector. Huh. Remove first item in a vec. Blah, blah, blah. How to remove an element from a vector given the element. Yeah. There's a method called remove, and it takes an index. There's a method called remove. Okay. Go back to the standard library, remove. Hash maps, B trees. What about vectors, linked lists, vector DQs? Where's vec itself then? It's here. Alright, we've got to vec. We've got to the structure of vec. Blah, 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 blah. So there'll be a remove on this. Indexing, okay. Yeah, I think we're okay with the indexing idea. Slicing. Oh. But we've got a move problem with that, haven't we? That's basically what we... Oh, no. Read slice and V. We just want to provide... Yeah. Same goes for stringers. Yeah, okay. We'll look at slices. Guarantees. Shrink to fit. Yeah, we might have to do that. Alright, capacity. Yeah, we're working with the heap. That's what I'm trying to do. Capacity, it's talking about capacities and all that kind of, with capacity. We've got extract. There's remove. Removes and returns the element at position index. Shifting all elements after it to the left. It does it all for us. So we don't want the column. We want to remove mute self and an index. And we get a string. But for some reason it's not quite liking it. Cannot mutate immutable variable. Okay. You like it now, do you? Oh. What's wrong with you? Value assigned to data is never read. I don't care about it being read. I'm trying to assign it. That's cleaned up that. We've removed that. We've now got our column. Have we? No, it's a row. This is interesting. We now have our row as a vector, and we have a name for our row. We're getting closer. I don't want to do a vector of vectors, do I? I think I do. I'm not sure. And what's wrong with row? Nothing. Okay. Underscore. Oh no. I see. What you're saying is, don't do that. Do that. Which means we don't need data at all. Yeah. We don't need that. We just need to take that off there and get rid of that. There we go. Alright. That's starting to look like real code again. That's going to give us back each line of the table. Huh. So we now have a table that's been split down by, well, we've converted a row. Problem is, we've used for line in table row data. That's wrong, isn't it? I mean, it's interesting, but it doesn't give us an iterator or an index. Aha. So. We may need to index here. As we need to be able to place that into that. The string for each row is different. That's correct. So we can push the string in. But what about... Ah, wait a minute, we can do that direct. We're just saying, calling it data. Alright. Is that possible? Not under the current circumstances, I don't think. Anyway. So, the data... Yeah, this is the problem. We don't have an index. It's a vector. Can we just push? I doubt we can, but we're going to try. The value now would be open brackets. Well, it's just table data, isn't it? It's already a tuple. It is a tuple, isn't it? Yeah, it is. Okay. I don't think that works. Okay, what's table data's problem? We're assigning it here. We don't need that. Okay, we can do a let. Which means we don't want you. Okay. Alright, we're cleaned up. Is that correct? Will that give us multiple lines? Ah, interesting. This is all wrong now. Still have this deserialize thing to do. Alright. So how do we get our data back out? As we are now getting this. Do we have to get a pair out? I just want the string part. Test table dot table. Yeah. First. Is there a first? Concat join split off. Splice. Oh my god. Did these guys eat a dictionary? searches, capacity, chunks. I just want the first item. Let's try it. That's going to give us a string and a string. That's not what we want. We've got an option coming out. From parts. Nightly. Fine. Pop. Removes the last element from a vector and returns it. No, I've got a tuple here. Is this an option? I think it's just an unknown. No, it is coming up with a known. How do we get a pointer to that string? Because that's what I'm after. And it isn't a 0, is it? Ah. This is interesting. Yeah, it's still giving back. Just want the first item. And as soon as I put a second dot in, it's going to say no thanks. Yeah, it's just going to give me both. Alright. How'd you get the first item from a tuple? Ah, there. How to access first variable in a tuple. Element at variable index of a tuple. Code sample. Let's try this. Oh my god. Long tuple. Alright, they've got this massive tuple. First value equals long tuple dot 0. Really? I'm allowed to just put dot 0? It's telling me it's unknown. Either you're lying to me, or there's something I'm not seeing here. No field 0 on type vec string. Oh right, so it's 0.0. Oh my god. Worked it out. joking me? We're allowed to do that. So to deserialize, we'd need the table. We're looking at 0. Dot 1 index 1. That doesn't look good, does it? That looks confusing as hell and hard to read. We were getting a ball at 125.5. We're now out of bounds. Column 1, 7 and 7. Okay. At 1972. We're out of bounds there. Well, yeah, of course we are. Alright. We shouldn't be. Ooh, that doesn't look good. Alright. I know I put the wrong number in. I have to admit, this is fascinating to me. Sorry. Yeah, we are out of bounds. Somehow we're losing our length. It's not a push, is it? Is it? We can't do that. You see how what index out of bounds, the length is 0, but the index is 0. You can't do that. That is just bad ideas. That's not right. I'll put a 0 in here, that's why. Let's put in a 1. Ah. Alright, let's try you out. It worked, but we didn't get our first part of the data. We got 500. Different result, which means we did get that one there, which is the actual one we wanted. We were getting a bad result last time because we were overwriting our first row. We're now keeping our first row. But our string is being overwritten, isn't it? Oh, bollocks. We're extracting it and we're putting it in string. Is string being overwritten? Yeah, it is. So when that goes in the second time, string is overwritten. That's a vector. God damn it. You're a vector. So now we know how to deal with that. It isn't a push. Or is it? It's coming back as a string and a vec, right, okay. Is this a hash map? With a key pair? Looking at what I'm doing, I'm creating a bloody hash map here. I just recognise what I'm writing. My God, how does that work? Holy mackerel. Ah. Oh, data manipulation. You're so funny. At least I showed you how to deserialize things. Okay. You see what you discover when you're doing things from scratch. How do we want to access this? We want to be able to put in row and column. The column will go to the nth row. Do we really need? Yeah, we do. We need to know the row number. This is just a row number. We don't need to split off. I'm seeing if I can simplify it. Into something that's going to be actually usable. I mean, we're able to simplify this, but we've now got a for loop in our create. Not happy about that. But we did manage to get this sorted out, and we can split off and remove things. That's good news. But our string is being overwritten. Or not written to properly. I think that's a push. But vex string is separate, it's not a key value. Yeah, it's a key pair. My. So is that map, hash map? What is it in this language? We've got a key pair. Where the row's name really doesn't need to be removed, but we have, and that's awkward because it has to be added back in to be able to save the data out. I think I've caused myself a problem there. Hell, it works. We can do it without the hash map. For now. I want something that's working. We could ID it. I want to fix everything else before I start messing around with hash maps. We don't need that vex string. We don't need any of that. Alright. Let's get rid of it. Let's just keep it as a straight vector. Let's simplify all of this absolute garbage that I've done. So we need to... Table row is still a vex string. That is still a vector vex. Alright. Let's remove this from here. Okay. I'm happy with that. That's a vex string. We can just return it. We don't need all of this garbage. We don't need a print line. Yeah, I told you it's simplified it. Am I allowed to do that, or have we got an unwrap in here? We have an unwrap in here, don't we? Okay. We just return row. You're no longer used. Does not need to be mutable. I agree. Okay, it is happy with that. That's fine. Doesn't that simplify nicely? Except for the command. That's okay. Data's struggling. Yeah, it will be. It's a vector of vex. Well, let's make you into a vector of vex. We've got brackets we don't need. Okay. Fine. That's okay. That's okay. That's alright. We've simplified everything down now to something that works. We've got brackets we don't need up here. Alright. Take those out. Okay. Data push. Table data. For each line. Yeah. I'm going to go with that. Here, we don't need that 0 anymore, because that is 0. We don't need that anymore. God, this simplifies out. It's not liking that part. Arguments this function are incorrect. This is on Deserialize. You just want an and string. What are we giving you? We're giving you a vector. I want the value. Yeah, we're given the vector. Okay. I don't want the vector. Test table, table. Table, which is the vector. Or should be. Let me just think on that. This is not straightforward, is it? How to access that? Why is it giving us that? I'm not quite sure. All right, we've got an and vec string. That's why. We've got a vector of vectors. Zero, I guess. Have you got anything in there? No. Oh, there's no dot. Silly me. I recognise that. That's used in matrices if you don't want to know. Okay. Glad I recognise the pattern. Alright, so this is table 0 and we want 1. What's wrong with that? What are we getting? We're getting and string. String. Okay, we do need that ampersand sign in there. Alright. That's better. Ah, this looks more like what I wanted. Now I'm familiar with that notation. So we are going for row 0, column 0, row 0, column 1. And that's the notation. Which is the same notation I use for matrices when doing things like OpenGL graphics. Exactly the same type of idea. Okay. Computer's saying everything's working. We are still getting an F32. Oh, good. We've still got a length of 0 coming out. We're not getting a printout now of our length, are we? Okay, let's start getting some printouts and finding out where it's going wrong again. Oops. Where? Main RS at 18. Our string isn't coming back. Is this not working? we'll pop you in. Oh, God help us. This is just row. And that's row. Okay, let's try that. Find out what the hell's going on in here. Row length 7, row length 7, table data length equals 3. We've got 3 rows. We should only have 2. We've got an extra table data length. You shouldn't have initialized it there. We can't do that because it isn't initialized. Bloody hell. And data's uninitialized, yeah, I know. This is in the wrong place. We have to get rid of that variable. So this is in the wrong place. That's what it's telling me. That doesn't belong there. Does belong here. God damn it. We've got the same problem here. Because of that. Because now what we're trying to do is exactly the same thing. We're just moving the problem, aren't we? think we are. What's wrong with table? Oh, it's a vector. Oh, that's only giving us a vector of strings back. All right. This is where it goes wrong. Because we need a vector. We need that result there. We need a conversion here. I'm just going to do a simple conversion for a minute. Which it doesn't like. Semicolon. Ooh. Yeah. I'm dubious about what I'm doing here. Very, 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 very dubious. Can I do... Can I do something stupid on here? Like, vec pling. That's gonna be God knows what. Dot push. We can. Oh my god. Push data. Would that actually give us something? Let final equal whatever I just typed in there. It doesn't like that kind of idea, that's fine. Final. Blah 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 equals that thing there. Don't think this kind of thing is allowed in Rust. That's what I'm after. Which should actually equal a vector of vec that we do still have an error. Syntax error. Expected expression. Right, that makes sense. That doesn't make sense. That's a pattern. It's not complaining about it though. I don't think our push data is being very useful. Maybe. Hold on a minute. It's not liking the push. R angle. Oh, of course. What? Yeah, I don't like any of this. Let's just get rid of that for a minute. Equals something. Final has to be mutable. It's a vector of vectors of some things. Expected a name. What am I getting if I get rid of you? I'm getting a vector of vec unknown. Okay. All right. I'm taking you out. No, it's correct. Damn you. But how do I get to it? How do I get to this final value? Yeah, this isn't working. Wow. That's amazing. I'm going to have to stop at this point because I'm in a rabbit hole. Aren't I? That doesn't help. This has to come back as a vec of X strings. Oh my god. Oh, fathers. That is data. Let data can't come through that thing there. Okay, where's that thing going to? Self. That's wrong. Okay. That's no right. Alright, thank you. It isn't underline anymore. It is this thing. It is a vec string. Okay. Pushing it. Yeah, that's right. Okay. That's row data. Thank you. Let row, blah, 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 split white space. We've got a vec of strings. We need... No, we haven't. We've got something for each, for line string. All right, I've got you now. For line string in do. So let row. This is now a line. Okay. And then we get to this data push business, which is wrong. Okay. I can just go at data 0, can't I? Yeah, we can. Data 0 dot push. Yeah, and that would be row. It doesn't really like it. Expected struct string. We got the vec of a string. Yeah, we did. Do we collect them? Map them again? Because we've mapped them into a vector string. Got this for loop going on. That's a for next loop. If I'm doing it that way. Isn't it? Basically what I've written there is for index in 0 to row length. And that's index. That's what I've written. We can't have that because it doesn't exist. So we'll put data in there for now. And we have to return data. I mean, I'm doing this the worst way possible as I normally do. It's still not liking that. Cannot move out of that. Can we do it that way? Looks like we can. We have to put a factor in there, so we'll just put 0 in for now. Why aren't you letting me do that? Used binding, data isn't initialized. I'm getting a little bit annoyed at that. Data isn't initialized. But we're initializing it here, you little skunk. How do we initialize that? Does that mean I can print stuff out? I can. This is very dubious, isn't it? And we're going on way too long. Yeah. But I'm having too much fun, so do apologise. Because I'm learning. Length is 0. Source data RS 3617. Oh. We're referencing 0 that doesn't exist. Huh. We have to... That is in a vector string, isn't it? This is a vector. Get rid of the indexing. Okay, so that's the whole row going in. Alright. Interesting result. We got bat at 500. Row length, table data length 2. Which means I got it right. I'm glad I thought my way through that. And we've got deserialization going on. So we didn't need that. Wow. God, this is bad code. I always say that, don't I? Format the document, please. Get it right. Oh my God. How did I manage that? I simplified it down and we got the correct result. But how are we now accessing it? We're still accessing it the same way. Ha. Really? Row length is 7, correct. I think it's correct. I haven't counted. Let's check. 1, 2, 3, 4, 5, 6, 7, correct. There's no \n going on. What happens if we take the 7th? Do we get that \n? It's supposed to be an F32. Is it a 7 or is it a 6? There's a 0 involved. We'll go 6. We'll give it a value of 7. I want to see if we get a 0 or a 7 there. I need to know these sizes. Yeah, 7.7 was right. It's -1. It bloody works. So that's 0. That works. Oh, damn it. We've done it. We've got a table. If I go now for 1, this will give us 150.0. Okay. That should also work. Ball 150. Ball 150. We've done it. We've created a table. I thought through the complexities, nearly went into hash map territory. It looks as though we don't need to go that far. That's deserialization for you, completing 1 line of code. Well done, me. It's a bit more complicated than that, but we'll get there. This code is very testy, but that's okay. Convert rows. Print line we don't need. We are getting table data. This is actually okay. Holy crap, we simplified that. I'm going to take it as our first table. I'm going to pull this to pieces over the week, learn more about it, and hopefully we'll come back to that. But we need to rewrite our time thing as well. So this is first table with Deserialize F32. Yeah. That's interesting. I got no sound. Oh, are you getting sound on here? That's interesting. I got no sound. Oh, are you getting sound on here? Huh. Windows is messing me around again. We'll see. Yeah, I have my sound at 50%. I don't like lots of it. I've got very sensitive hearing. First table with deserialization, etc., etc. We're all done, I believe. We did do it in 2 files. I'll need to clean this up. That's only one table though. What happens if you have multiple tables? That's the next question. And how can we deserialize more than an F32? That's the other question. The test data seems alright, we can alter things. We should write the test better. We've got magic numbers in it. I don't know how much more to say. What more to say about this? It's not. It's nowhere near a final version, obviously, but it does give us an idea that we can put a table in here, and we can convert rows. Or well, this is deserialization. Well, it isn't. It's half of half. It's part of it. It isn't really. It's just converting rows into rows and columns by splitting it all down, which was awkward enough with strings. But we have managed to keep everything in string format. Everything's on the heap. Yeah. Everything's in the right memory. And that's important. I mean, I've been forcing it to go that way. I'm going to think about it. We'll have to stop though, because we're at over 4 hours and I've completely lost track of time because I'm really having good fun with it. And we'll have to get on with our day. Look into something called food and things like that. So did we get a data table? Yeah. Did we deserialize? Yeah. I hope that gives you some fundamental ideas on how it's going to be done. What we have to solve. And things like that. We only have a single table at the moment. We only have a single type of deserialization for the F32. But we have the fundamental basis of what we're going to try and do. That's going to be interesting. It gets even more interesting when you want to deserialize multiple things, because you need to know the types. And we have to be able to do that automatically. So, until next time, what we're doing next time, probably rewriting the clock, I think. Yeah, I think we might do that clock rewrite because I'm a bit annoyed that I didn't get it right. But the first time I do something, I never get it right, so. Okay. Alrighty. We'll go with that. You lot take care. Thanks for popping by, and have fun.